thanks for having me. My name is Scott Levin. I'm at Johns Hopkins University. I'm a faculty member there. I'm the associate director of research, and but I'm not a physician. I'm actually a biomedical engineer that's been working in emergency medicine for like 20 plus years now, and I'm going to be talking largely about some of the technology development and testing. In the pipeline of that, of doing a research project, and then I do want to disclose that our research group does have a company that takes some of these tools that we. So once we prove some of the technologies at Hopkins, have been able to bring them out to some other hospitals, and that's after a lot of failures, I will say, at Hopkins doing this type of work. Just to give you a very high-level picture of the way at least our group thinks about a project is really these stages from an idea to software. So most folks, I feel like, are in this mode here, as Andrew was talking about, where there's capture of data, problem definition. I think it starts getting a little bit, there's the survival curve, I think, drops really hard when we get to talking about creating like a real solution that works in real time, or a prototype software. And then there's, of course, deploying that solution locally, doing the impact, what's the impact of that solution locally, and then if it's worthwhile, trying to figure out how to scale it, either across a set of hospitals or even outside to multiple hospitals. I will say the fact that the electronic health record is consolidated into, at this point, Epic and Cerner, Meditech, it makes it very helpful to actually make this happen, whereas I feel like 10, 15 years ago it wouldn't have been. The other thing to note is, one of the reasons we started the company, and I just generally do work with industry a lot, is because industry is good at things that academics isn't, or that our local hospitals aren't. And you can kind of see where I think the partnership works, where I do feel like, being in an ED, the ideas, the problems really need to come from you all. And then, of course, including defining the problem. Whether that is a problem that is experienced across the country is, I think, where to some extent industry can help. But then, of course, like developing the solution and deploying is where there are folks in industry that have skill sets that are rare to see in hospitals, and so that's where we're partnering to. And then there's, of course, impact analysis. So there's a whole set of statistical tools that I think many haven't spoke about here yet, around how do you evaluate an intervention over time? Is it having an impact? Which I think is very difficult in this space, because we're typically not doing randomized control trials, or may not be doing randomized control trials. We've debated doing things like that, but when you're trying to implement a technology and train, we found that it's easiest to just, this is the new process, or this is the tool that's going to be put in. So you're left with some pre-post analysis and types of methods that you have to do to evaluate, well, what was going on before the tool was there, the technology there, versus what is happening after, and all the confounding that is part of that. So I'll just give you an example of like some of the CDS software we developed, and these are just the interfaces of what it looks. So I was speaking before about a tool that we have functioning at triage, where we are able to support the triage nurse's decision in Epic or in Cerner, right in line with the current workflow, where we're predicting different risk of acute care events that occur, and able to consume like past medical history, vital signs, all the information that's available to the time at the time that the triage decision is being made, and often some things that are not available necessarily to the nurse, since it's a 2-minute process. So there's a lot of opportunity, I feel like, for us that are doing this AI work, where you guys are so busy. You're taking care of 20 patients at the same time. if you watch, and from the outside, I watch you all work, and I watch an inpatient doc work, and the time that they spend combing through a patient's chart before they walk into a room, it's just, I think there's a lot of opportunity, not necessarily for fancy predictive models, but just to get you all the data you need to make a decision in the time that you reasonably need to make it. And I feel like that's part of our group of the work that our folks like us should be doing. But we have this triage CDS. We have a tool that supports disposition decision making. So in Epic, right when you get to the disposition navigator section, you'll have some information about what we recommend and why. And this was to really, during COVID, there was a new option to send patients to a field hospital. And so who should be those patients? And so we have a tool that's still running, supporting that decision. And then even on the inpatient side, things to support patient flow around, are these patients medically ready to be discharged? And can we support the multidisciplinary round? So just a number of different tools that are really deeply embedded into Epic or Cerner and fit into what the workflow that currently is there. And I've found that you really have to do that. You can't, the workflow, albeit sometimes the workflow directly in the EHR is not desirable, it's what it is. And so we have to just really, I think, build into that and make it so if something takes more time or requires extra data entry, to me it's like a non-starter at this point. One thing to know when you're, I'm going to talk more about deploying a tool and the technology you have to build to actually deploy. One of the first things I think is underappreciated is what type of CDS are you trying to execute. So there's ones that are an event trigger, meaning an event occurs, the triage tool, the patient's at triage, that event, patient first arrives and they're not triaged, that event triggers the clinical decision support. It's passive and in the EHR at the location where the decision is being made. And then you have like surveillance-based triggers, and this is like a lot of the self-sys algorithms that may be picking up information every 10 minutes. They're scraping new information. If you want to build a CDS, the first thing to think about is, am I triggering? Do I want an event to trigger the output back to the user, or should it be? And is it passive within the workflow, or is it something where we want to do surveillance and actually change the workflow? So we're doing surveillance and we notice something's going wrong. Do we want to alert the physician to change what they were doing, which is a whole different kind of mindset and science around the development, but it's also very different architecture in how you build the tool. This is generally like at a very high level what the software is, or what these components of the to interoperate with the EHR. So you have like the production environment. So that's the real-time environment in Epic or in Cerner. That's where data is being exchanged. You pull things up and you're using it. Then there's the data repository. So, and that has multiple layers. So there's Clarity is the data repository for Epic, and then there's the data warehouse, which is a way to make sense more of Clarity. But generally, when we're building, our research team is building tools, we want to go to the rawest form of the data. We don't really want to work with abstractions that other folks are doing. And so we do have a lot of data infrastructure and warehouses, but we'll say, I want to go right to Clarity. And the reason is because if we build this at another hospital, they're not going to have data warehouse XYZ like we have. So for generalizability reasons, we're very much focused on going to the raw source of the data. And then, we'll use, some others spoke about different real-time communication mechanisms, FHIR, HL7, and then there's private APIs that are offered by the EHR. Every tool we've built has required all three. Never been able to build an application that only can use FHIR, only can use the private API. So you sort of have to use all three, but there are these places, like you can see the Epic App Orchard and the Cerner code environment, where you can get linked up with them, and they can show you how, if you're going to build something locally, is this going to work if we transport it to another place? And those environments have matured a lot. But we bring the data out onto the cloud. We build models from retrospective data, and then deploy them in real time on the cloud. And so a lot of folks have been talking about like this process of getting retrospective data. I'll say that one of the things when you're building an application is the assumption that real-time data looks the same as retrospective data is very much a false, is not true. So we do a ton of work kind of in here and in here reconciling. This is what data looks at a particular point in time versus this is when you get it in retrospect. And examples are retrospective fields are updated. Sometimes you have to go really deep into Epic or Cerner to determine the auditing of how that changed over time. So you don't want to use, obviously if you're building a predictive model to support a decision at a point in time, you don't want to use data that's not available at that point in time. And then there's a bunch of performance monitoring that I'll kind of talk about. But first, this data factory, when we talk about like getting data out of Epic, and we've seen, or Cerner, and we've seen kind of a lot of different models, including business models for doing this. What we're generally doing is we find that if we go to a site, we need to deliver them the Clarity code or the code to Cerner that will get, that basically the SQL that will get the data in a standardized way. And so that's what we do. And we usually work with an analyst at one of the sites. And within an hour, we're just running through our code that we're applying in their system. And within an hour, usually, we're able to get it. And so at that point, from the hospital, we end up with, I would call, standard-ish data. And so then once you see that, we do a lot of processing on our end. You start seeing where the differences are. I'd say about, like in Epic sites, it's about 85% of the data is the same wherever you go. In Cerner, there's a little bit more variability. But this is generally our process. And even in our research group, we're building these queries. We're creating a retrospective data set one time. We're doing our research. But then what we're doing is we're creating like a registry where we're able to apply that code back to continually update. So we have a number of, at Hopkins in EM, a number of different databases that are just refreshing and updating. And Aria, who's in the room, is the one who builds all that. So she's a good person to talk to. And so once we have this factory going, we have tons of research projects from folks from all over the institution doing work because they're getting it and they're getting it in an updated way. But we're very much focused on the process and the pipeline, and again, starting from the raw data. So another important component of like building a real-time tool, and part of what I'm saying is reason I'm talking about some of this is locally we get a lot of folks saying, I want to build this tool. And it's a doc and maybe they got some support from IT, but there's a lot of resources that need to go into actually deploying a real-time tool. And a lot of it has to do with like this real-time and retro reconciliation. So when we'll deploy those tools that you saw in the EHR, some of the interfaces, we're tracking like well, on the quality side, we're tracking data integrity. So all of a sudden, are we missing chief complaint? Are we missing vital signs? Are we missing labs? Does something not make sense about the basic characteristics of this data? So we have a pipeline that monitors all that. Integration performance. So all of a sudden, does our HL7 feed that usually takes a fraction of a second to get back, all of a sudden, is that taking 10 seconds? What's happening? So we track all the timing of events. And in emergency medicine, with all of our tools that we've put in, this thing has to happen fast. We've got to get feedback back fast to the provider. And then, of course, there's your general model performance, which we're tracking over time. But whenever I see model performance go down, it's usually because of data integrity. It's usually because something changed in the system about the way something was input. Because in EM, I think we're so lucky to have such large-scale data that when we do build these models, they end up being fairly stable. And then, of course, like another component of the performance monitoring is the impact assessment. So this is where we're looking at the metrics that you're trying to improve. So are we improving? We were just speaking before, but we have a disposition tool that's designed to minimize bounce-ups from the floor to the ICU. So we track those metrics over time. We do longitudinal analysis. and often, like, I don't know, segmented regression. So it's just a method to say, before this tool is in place versus after, is there a change? And what are some other things that could have driven this change? Volume in the hospital. What are some of the confounding factors? And you can put it into models to say, a segmented regression model to say, okay, this change occurs, statistically significant, and it looks like after controlling for these confounders, it either remains statistically significant or not. But often we're looking at a lot of clinical data here and operational. So most tools that we've built, in order to get enough support behind them, they've had to have a pretty meaningful operational improvement. So all of that to say is we're focused on the triage decision happens for every single patient that walks into the ED. Disposition decision, every single patient has the. We'll often want to tackle some problems that are maybe a lower volume of patients, but really haven't been able to kind of get the support to get those going. The last thing I'll talk about is just this. That's like the technology and the pipeline of mostly focusing on deployment. But scientifically, this is how we're sort of going from that idea to a tool every time, really. And it's and this is what we'll put in all of our grants and things. And most of this work is funded by grants. But they call it a hybrid implementation effectiveness design. And it's where, and we've been focusing a lot in these talks around step one, where you create an algorithm, you scope the problem, you measure it retrospectively. That's really all step one. But then once you get into step two, which is where you've decided I'm going to create an application, we generally try to focus on the implementation. What's the best way to implement this intervention? And there's, typically we'll design it, we'll do mock-ups and things like that. Then we'll get it into the test environment of the EHR so folks can play with it. But ultimately, we want to get to the point where we do a silent go live. So we'll run the tool in the background for a period of time where it can evaluate it prospectively. Show the clinicians this is what we expect to happen. This is the differences. This is the potential value. And then we go live. And then, of course, there's at a certain point, then becomes the post-intervention evaluation with some of these longitudinal tools that I spoke about. But generally, this is our scientific approach and the pathway of going from these ideas to something real and usable. So that's all I got.
Question for you about the long term. So obviously there's a lot of investment that needs to go into doing each one of these and testing each one of them. Do you see like a long-term solution to not just deploying one or two models, but 50, 100, like 1,000 models in a system? And we're talking about like a learning healthcare system that truly incorporates all AI has to offer.
Yeah. No, I think like once you can do one project, you get some infrastructure going, and then the idea is, can it be scaled to other problems? And I think it's certainly possible. And it's I think what happens in academics, especially if you're research focused, is you just have to do project by project. That's how the IRB works. That's how grants work. So it's sort of the model of working scatters you. But then from an engineering standpoint, you want to do exactly what you're saying and continuing to build. So I think that's another reason the academic model is a bit challenging sometimes to build these larger scale things.